Okay, I have transferred the audio and video over on the YouTube stream, and someone should signal from that chat box that y'all can hear us. Here is the agenda. And we will get started. First thing on our agenda today is some testing updates. Proto, and I think you've been spending most time on testing. Do you have any updates for us?
No big updates here, I suppose. Although 0.6.1 is interesting. We have been dabbling with the idea where we can unify some of the testing between the PyTests, the test that test the spec, and the test that implement or the test generators, the vectors for the clients. And so it's like the common part here is this setup part, where we set up an edge case, and this edge case is applicable to both types of tests. I'm not sure if it will make 0.6.1. Likely not. But do see it like being like released in the next week or so.
Cool. And there's a pending PR that brings that minimal SSD implementation up to 0.6.0 and 0.6.1. That we want to get merged in, so we'll have SSD tests for the new release.
I've implemented SOS and minimal SSE. I'm currently working on a rewrite of the minimal SSE code, or well, big refactor, to make it like close to executable spec and much nicer to read. So there's many issues with non-typing and these other like readability things, and we don't really want the separate Python file that needs to be updated all the time when there's a change. And then union and null types are being implemented as well.
Great, thank you. Anything else on testing before we move on?
I don't think so.
Yeah, cool. I know there's a couple of pending PRs with some tests being added that we're keeping in a holding pattern until we sort out the edge case stuff that Proto was talking about. Okay, cool. We'll move on to client updates. Let's start with Nimbus.
Hey, Danny, I think you broke up a little bit.
Oh, sorry. Can you hear me?
Yeah.
Yes.
Yeah, I can hear you now.
We're going to start with Nimbus, if that's cool.
Yeah, perfect. So we closed our agenda for the past 6 months and opened our new plan for the next 6 months regarding Ethereum 2.0. So this was in the chat the closed issue and the new open one. So we will dispatch team members. So if you want to know who is working on what within the team, you will be able to check out this like next week or so. Otherwise, regarding updates on the core spec, we started to implement 0.6. We have state transition changes partially done. Our current focus is on the get beacon proposer index that was reworked significantly in 0.6. And it's a blocker for us for several things like fork choice tests and state pooling, something to optimize everything related to state. Another issue is that we found some underflows with Genesis Epoch, and we're interested into what other users of statically compiled language with unsigned int, do they also met the same Genesis Epoch issues? Because in Python, since it's always signed integers. Maybe that's hidden.
Yeah, and it was. We have a PR up, although we're still figuring out the best way to do this, for handling the particular underflows, and also potentially overriding some of the integer operators in our testing to make sure that we don't hit those underflows and overflows.
Okay, cool. Because otherwise we would have gone like nuclear with assert everywhere to check if we underflows. But we might do that anyway. And also regarding SOS, so right now we are thinking on how to update the library and, for example, how to read fields without deserializing everything, which is like the big upsell of SOS. So that's it for core. And now regarding networking, we added the NAT traversal to beacon chain simulator. So now we have much better connectivity, even if everyone is behind routers. And the testnet was not working on Windows due to NAT traversal. We had some Windows socket issue, and this is fixed. So right now we are implementing chunked encoding, and there is more of a low-level question, but how to design async networking using either streams or transports, which is the best way. And regarding testing, so we're very happy to see the updated test suites, and we managed to we were surprised by how easy Git LFS was to use or clone. Right now, since we don't have state tests for 0.6, and we don't have SSZ SOS style either, we're working on just shuffling. And something that is coming quite often is like mocking blocks and attestations for testing is a bit complex, and somehow the Python spec tester managed to get away with very simple things. So we are looking also into that. And that's it for us.
Great, thank you. How about load start?
Hey, sorry, I thought Cayman was going to be on this call. So we were up to date with 0.6 for SSZ and the beacon chain. We're hooking up the testnet suite right now, so we don't actually know what's breaking, but I'm assuming.
We have a last few weeks we optimized.
Sorry, Greg was talking, but
all yours, Cayman. You can take it, my guy. I think we've got latency issues.
Yeah, it seems like it.
Yeah. Okay, I'll just finish up. Sorry about that, Cayman. I think there's like some serious latency. Oh, now I lost my track. Yeah, so we're up to 0.06, and just kind of waiting to see what the tests say at the end of it. And we just actually merged in flood sub. No, pub sub, flood sub, and we're going to be using that kind of as like a test ground, as well as we've got. So we're going to do that in Hobbits, and basically, yeah, with 0.6, we're kind of seeing what's going to happen with test suite. We have SSZ up to date, and we have to make some we had to contact Harumi to make some modifications to PLS. We're still convinced we're going to continue with Harumi's implementation just for diversity. But there's a few issues with it, so we're dealing with that. We've started to kind of separate out the validator from the actual beacon chain, kind of have its own little thing. So we're using the RPC, kind of like roughly implementing from what Luke's proposed RPC methods are for the validator communication. We've implemented Omni Ghost, like kind of re-optimize it from Proto's algo, and anything else? Nope, that's about it. Sorry, I had to take notes from like Cayman.
Proto Lambda raised his hand.
So like this Monday, I found an even better way of implementing AMD-cast. I'm still working on it, but that may be interesting. So
This guy.
Awesome.
Good. I'm excited.
Cool. Thank you. How about Pegasus?
Hey, sorry, just looking for that mute button. Okay, so our master branch, is my audio okay?
Yep.
Cool. Okay, so our master branch is on 0.4, and we have been working on a branch for a while now, targeting 0.5.1. These past 2 weeks, we made modifications to our SSD implementation to account for the types introduced in 5.1. So we updated and added kind of like a JSON and time series CSV logging to our client so that we can kind of get that into the Whiteblock platform. We've been troubleshooting some issues with validators. And I'm trying to remember exactly. It's the function that validates the Merkle branch, right, from the deposits. And so yeah, part of in doing that, we've generated some test data from the deposit contracts, and we'll be sharing that shortly, I think. And organizing and planning this workshop, but mostly just troubleshooting our 0.5.1 branch. And that's it. Any questions?
Nope. Great. Thank you. How about Harmony?
Yeah, we finished incremental hashing feature on this week. We expect list support, some performance tweaks and refactoring. Also, we have added cool benchmark tool, which works only with spec. So it provides output for all spec methods, how many times they were called, for how much time, etc. And we finished adoption of new tests, which is currently in ETH2 spec. And now we finish and moving to 0.6.0. I think it's in a day or so. And working on wire and sync protocol. And that's all, I think.
Cool. Thanks. Prismatic?
Hey guys, we've been working a lot on making our testing more resilient. So now we've been trying with a lot of people kind of just privately joining and having more validators, survive through multiple catastrophic scenarios. Pretty nice. And overall, just like really, we have a parallel track where we're updating everything to version 0.6. So we're around halfway there with all the v0.6 updates. Our testing will probably go live with around v0.4 with some bug fixes from latest releases. And yeah, that's mostly what we've been up to recently, just fixing that up. We removed all the like O of n squared blowups in the spec and like epoch processing. So we managed to optimize some stuff by like 400x, which is pretty nice. So yeah, aside from that, just cleaning things up and getting things ready.
Great. Thank you. Trinity?
Oh, hi. So we recently implemented the basic validator service in Trinity. And we also integrated with the test suite of the version 0.5.1. And I think we will start the target on the 0.6.1 upgrades next week. And then the focus choice rule and the beacon chain plugin are work in progress. The plugin is the module that intended to extend the functionality. Yes, and that we call that the beacon chain plugin. I think that's it. Thank you.
Thank you. How about Lighthouse?
Yep. So we've been assisting with the interchain BLS standardization efforts, and we've had a kind of a long-standing issue that's getting our node when it's syncing to catch up to blocks. We've managed to solve a lot of those issues by implementing cached Merkle hashing, which has helped us with some massive speed gains. We're also, similar to everybody else, working on updating to version 6 of the spec. And we've started looking into and designing how we're going to implement disk v5 in the context of libp2p. That's us.
Cool. Thank you. Is there anyone from Parity here? Cool. And Yeeth and Geth, I don't think so. Great. Thank you, everyone. Let's move on to research updates. Anyone want to get us started?
So the big research update from my side is probably the phase 2 proposal that's that I mentioned 2 days ago, and I put it up now on Eth Research. Let's see if I can find the. Here, I got the link. I'll paste it in the Telegram, and you can feel free to repaste it in the Zoom.
Paste it.
Yeah. So, I guess just to kind of do the quick presentation about it. The basic idea is that this is meant to be a proposal for kind of the core of how phase 2 state execution would work. And it's specifically taking the direction of having a relatively minimal kind of consensus layer execution system. So it's not quite as minimal as the proposal that Casey made in Eth Research a couple of weeks ago. So this proposal does have execution happening in different shards, does have state roots for different shards, and it does have some amount of state storage for different shards. But the consensus layer stuff is deliberately extremely minimal. It's only a couple of hundred lines of spec. And the idea is that everything else that you would expect to get built on top would instead be built using a kind of layer 2 framework that's designed inside of this relatively minimal base layer. So if you go through the document, there's kind of there's a few major subsections. So the first 2 big subsections that are there's some small ones at the start, but then there's the beacon chain changes section and the shard processing section basically define what the actual protocol level changes would be. And the basic idea behind this is that at consensus layer, contracts, and I call them precompilers here, but the name is totally not final, would only exist on the beacon chain. So the consensus layer would only recognize contracts as existing on the beacon chain, so they will be verified and stored by everyone. And these contracts can hold ETH, and they also have functions that you can call. And if and in this proposal, Ether as a kind of base layer thing can only exist on the beacon chain, right? So Ether is either held by a validator or it's being held by a precompile. So you can have there's a few new beacon chain operations that I introduce, but the basic idea is that one of them is creating a new precompile and the other 2 are transferring ETH from a validator to a precompile, and from a precompile to a validator. Now, there is, even though the contracts kind of are stored and live on the beacon chain, there is no code execution per se happening on the beacon chain. And that still does happen on the shard chains. And so the way that that works is that you have so the code that lives on the beacon chain, but the execution still happens inside of shards. So the only nodes that actually run that actually execute anything basically are nodes that are inside of the crosslink committee or the persistent committee of a shard at some particular time. So basically, a transaction that's inside of a shard has to specify what shard it's for, and it also has to specify what precompile it's kind of attached to. And if you have, basically the state transition function for a transaction is to execute the code of the precompile that the transaction is calling using the contents of the transaction as an input. So basically the transaction just specifies kind of what the state transition function is that it's paying attention to. The code has access to a foreign function interface, which gives it the ability to read and write from a particular region of state in the shard, and issue receipts, and to execute basically arbitrary code that you provide to it. So like even though contracts don't exist inside of shards as a base level concept, you could still kind of make contracts exist as a higher level concept by just setting up a precompile that under certain conditions like loads code from the state and then executes the code using some other data provided as input. So what so that's the first section and the second section. The third section, so this is implementing in-shard ETH transfers, and the fourth section dealing with expiry. Both have to do with basically giving an example of what it would actually look like to implement a kind of layer 2 thing that does something useful on top of this as a framework. Right, so the scheme that those two sections try to build out is basically a scheme for allowing people to hold and ETH inside of shards and transfer ETH to each other inside of shards. And the third section basically defines three functions. So one of them is like depositing ETH into the system. The second is transferring ETH, and the third is withdrawing ETH back to a validator. And if you own ETH inside of the system, then the way that what it looks like at consensus layer is that when you're depositing, you are both transferring ETH from your validator into the precompile, but also issuing a receipt. And then you can send a transaction in a shard which claims that receipt, and inside of the shard saves a record that says that some of that ETH that you just transferred into the precompile actually does belong to you. And then to send ETH to other people, you would just be sending transactions that call the transfer function. You would be transferring these records of ownership, adjusting balances. And then to withdraw, you would first call the withdraw function using a transaction inside of a shard, and then that would generate a receipt. And then on the beacon chain level, you would call the new validator function, which would consume a Merkle proof of a receipt of the receipt that you generated inside of a shard, and it would withdraw ETH from the precompile into a validator slot for you. And like this framework is really or that particular second layer system is like deliberately really simple. Like all it does is it just lets you move ETH around, but describe like at the very bottom in the fifth section how to basically what you would have to do to extend that into a scheme where you can just implement an entire smart contract system on top of it. And then in the sections below that, I talk about like how you would implement fee markets on top of this, what the resource requirements would look like, and so forth.
Yay, very exciting. I'm also in favor of minimalism generally for phase 2.
Mm-hmm. Yeah. Also, just as a general kind of comment about comments on this, I think the first big decision that we want to make is just like establish whether or not this kind of a kind of minimalism in sort of roughly the spirit of the proposal is the right direction to take. So it's probably not a good idea to just kind of start nitpicking, should the bit fields go forwards or backwards, or use big endian or whatever at the beginning. Like the goal of this isn't to make those fine-grained decisions at this point. The goal of this is to just be a fundamental proof of concept of the possibility of doing what we want to do using sort of minimal consensus layer and pushing more things to higher layers. And there's definitely a big design space of and trade-offs, finer grain trade-offs that we can make in terms of these base layer protocols. And I expect the kind of layer 2 schemes to just keep on improving over time, in the same way that, say, plasmas improve over time.
So just to put this a little bit more in context, these contracts that exist on the Beacon chain generally can be thought of kind of like execution environments.
Yeah.
And so by deferring it to these execution environments that can be built and upgraded over time, we've like become less opinionated on layer 1.
Yes.
Okay.
So unlike Vitalik, that's been thinking very high level, I've kind of gone the exact opposite, kind of continuing to fine comb, I guess, phase 0 in preparation for the spec freeze, which we're targeting for the 30th of June. I guess we're still very much on track. Still, simplifications are coming through, which is great, and the process of fine combing is also for finding these final bugs. One of the things that might be possible when we do a spec freeze, thanks to all these simplifications, both cosmetic and substantive, is that we might be able to fit the state transition function of phase 0 in 512 lines of code. So Proto showed how to do it in 1024 a few months ago, and we've definitely simplified it a lot since then. So if phase 2 is indeed a few hundred lines of code, and phase 1 is a few hundred lines of code, then as crazy as it sounds, like all of Ethereum 2.0 in terms of state transition functions for both the beacon chain and the shards might fit in 1,000 lines, which is amazing. I mean, that's assuming a few black boxes like SHA-256, BLS, and WASM. So one thing that we're doing a lot of progress on, kind of as a parallel effort, is BLS standardization. So I'd say we're very much on track for standardization to be completed by Q3, and in Q2 to have very good visibility as to what the final design will be. And generally speaking, things are lining up very, very nicely. So we have SHA-256 as a basic primitive on top of which we're building. We're reusing where possible what Zcash has done. And we have this new hash function, which has all these nice properties, including being hardware friendly, being constant time, being fast, and being simple in various ways. For example, only requiring basic field operations and not requiring stuff like blinding to get fast implementations. In terms of to-dos that I want to get done, before the spec freeze, one is the fork choice rule. It still needs some love. There's a few edge cases that are known, and it needs to be made executable. And I'm also working on the static state invariance, which will be nice in the context of first testing.
Great, thank you. Any updates from the Pegasus research team?
Just a quick one on Handle. We're actually working on some optimization and some extension of Handle to be able to resist DOS attack, where just you send a lot of signatures to someone, to a node, aggregating signatures, and yeah, we are searching on this front right now. Other than that, that's it.
Cool, thank you. Leo, do you have any updates?
No, not really. Updates.
Sure, thank you. Any other research updates before we move on? Cool. Move on to networking. Raul and Mike from Lippy2P are here. If you want to give us an update on what's going on Protocol Labs and P2P.
Yeah, sure. Hey guys, how's it going? So I started thinking about what to update you on, and I thought I just had a few items, and then I started drafting away, and there's really a lot of updates to share with you guys. So first of all, we have worked on the Gossip Server synchronous validators. This is a feature that many of you asked for. We've implemented recently in Go Lippy2P. The PR is under review right now, and we'll be bubbling this up to the daemon in the next few weeks. So it'll be available there. We recently merged the TLS 1.3 spec as well as the reference implementation in Go. We've introduced an experimental flag in IPFS, which we'll be using to roll this feature out slowly in the public network and conduct canary tests, essentially. We've hired a security firm to audit Lippy2P. They're auditing most of Lippy2P with the exception of SecIO, which will be phasing out and basically discouraging in favor of TLS 1.3 once the experiment is successful. Just a side note here, we're also interested in incorporating noise handshakes. Sorry, that's noise handshakes. So if you have any experience here and want to collaborate with the community, contact me, as we might actually produce a dev grant for this. So there might be some work in this area. We also have a dedicated engineer now getting our specs cleaned up finally and writing specs for unspecified areas. So we're putting together an impact plan, and we'll be publishing this as soon as it's solid. So basically expect kind of like a rough schedule of the specs that we plan to address and when they'll be available over the next weeks. We've also made progress with our test lab, which is a tool that we crafted to test Lippy2P at scale. The next logical step here is the network simulation, which is something that we're missing still. And there are really several actors in the decentralized space that are in need of a common low-level API that can be used programmatically to basically configure virtual NICs and link them and set up latencies, packet loss, jitter, and other network conditions, such that orchestrators, test orchestrators, can then use this API programmatically to configure different test scenarios, basically to test distributed systems under a variety of network conditions. And personally, I've seen several actors wanting this, and we're kind of like going our own different directions, and I'd like to create an open interest group in the community to start building basically a common asset, a common standard API for this, because as we get more and more sophisticated with testing these systems at scale, it is definitely something that many of us are going to need. So if you want to participate in this, then get in touch with me. I know that Zach from Whiteblock had done it this year, and I have discussed about this, and he'll probably be interested in joining as well. So another announcement, our friends at ZeroX and Pions are collaborating to bring libp2p, Go libp2p this is, into the browser by making it run nicely in WASM. One thing that they've done is they've created a WebRTC direct transport, which basically enables communication between the browser and the backend directly without the need of signaling servers. So this is great, kudos to them for taking the lead on that. And an aspect that we're starting to discuss a little bit is decentralized signaling in a Estern-like fashion for hole punching would look like. So if you have any thoughts about this, reach out and we can discuss this openly in the community. And last but not least, I wanted to put the upcoming IPFS camp up on your radar. This is basically a 4-day hacker retreat that's going to be taking place in beautiful Barcelona at the end of June. So this is between the 27th and the 30th of June. There's going to be a dedicated course for libp2p hackers that basically covers from A to Z of libp2p, as well as a lot of insightful workshops and discussions about challenges and upcoming features in peer-to-peer networking that we're already planning. So if you'd like to join, ping me and we'll get an application going for that. And I'll also be reaching out to a few of you via email, basically those whose email address I have. So that's all from me. Any questions?
Sorry, Raul, I didn't clearly understand why you want to, in which context do you want to use noise, so noise handshake?
So basically the idea would be to provide another alternative handshake mechanism. So as you know, a libp2p connection offers a number of guarantees. One of them is encryption and authentication. So we do offer SecIO as a mechanism here. TLS 1.3 is right now under test, and we wanted to start thinking and designing a noise handshake, and potentially, inspired by projects like WireGuard and others that are already using the noise IK handshake, for example.
Is this something like what Vuvuzela is doing?
Could be. We haven't really. This is basically an idea on the horizon now. It's something that we want to start thinking about and potentially start exploring. So we can definitely begin discussing different options here.
Hey, Raul, you said something about support for WebRTC so that code running in the browser could communicate directly with the backend. So is that different than so with WebSockets currently, can a browser talk to for example, the same code essentially running on Node.js, but it can't do browser to browser?
Yeah, that's correct. I think I'm gonna have to circle back on the exact difference between using WebRTC. I think it could have something to do with the WASM environment, but I'm not 100% sure here. But yeah, essentially, the WebRTC transport that currently exists is basically allows you to communicate with the backend directly. It doesn't. Maybe it has something to do with cross origin or something like that. I'm not entirely sure what the difference is right now, but I can circle back with you on that.
Okay, cool. Yeah, that'd be great. Thanks.
And related to that, have you considered also using gRPC, because there's some implementation from the browser that are starting to get out?
So the problem with gRPC, and we considered this in the context of another project, which is the network visualizer, the libp2p network visualizer that we're working on, is that it is not possible to access. It was something along the lines that it wasn't possible to access the low-level HTTP2 API from JavaScript, and I don't know if it's possible from WASM. So the problem with gRPC is that you can't really use it directly unless it's with a WebSockets binding or something like that, that I'm not sure is 100% stable. So there was something like that. We considered that in a different context, not in the context of a libp2p transport.
Okay, thanks.
So Greg has a question in the chat. What is the issue between browser to browser? So the issue is that a browser cannot openly accept connections directly unless it's with the signaling server. So when you're speaking with a backend directly, that is not a browser that is able to accept incoming connections without needing a signaling server, then the WebRTC, the kind of like the signaling part of the WebRTC stack becomes irrelevant for you. So that's where the WebRTC direct transport comes in.
So there's no ICE server there?
There is no ICE server there, correct. In that particular scenario. Something that would be super awesome is something that we want to dig further into is the feasibility of using a decentralized a decentralized signaling infrastructure. So this would essentially be peers on the network allowing you to signal to other peers in the network without relying on a centralized server, which I see, as you know, is inherently centralized.
Actually, that's a really cool idea.
Just a thought right now. So definitely just a thought. I think in Paris, I spoke to a few of you about this. It's just a thought, and we might like deem it completely unfeasible, but I think it warrants some intellectual exploration here, some research. So if anybody wants to collaborate here, please reach out.
Proto? No, thought you were cool. The next thing on the agenda is relevant to the P2P. I know that there's a couple of teams who are interested in figuring out, as they begin to work on Discovery v5, how to fit it into the context of the P2P. I know Felix isn't here, but I wanted to hear your thoughts on that, Raul. And there might be a conversation going on in a different channel, unless I'm incorrect. Raul.
Sorry, you were calling me out. I don't have any, so I'm just getting up to speed with the conversations in that channel. I wasn't aware of that, so I'll just directly respond. I started to respond to
cool.
some of the thoughts there, and I think we can keep a conversation there.
Cool. So there's an ongoing conversation in the dev P2P Gitter, I believe, around this.
Yeah, I think it would be great if maybe Adrian, who has sort of like taken the lead in this, would, like, once we finish discussing this on the channel and we have like some conclusions, if maybe Adrian could take the lead to summarize this in an issue somewhere so that it's visible to the rest of the community.
Yeah, that works with me.
Awesome. Thanks.
Excellent. Thank you.
Yeah, I'd be interested in hearing how it compares with existing discovery methods in the P2P as well.
Cool. Are there any more questions for Raul before we move on? Great. I penciled in gossip sub testing because I know Zach and Whiteblock guys are working on that. Is there any update on that? I'm not sure if we have anyone from Whiteblock today. Okay, don't think so. Cool. And then there's a couple of pending PRs that I'd like to get merged in relatively soon on networking stuff. I know that there's some comments there that I haven't taken a look at yet. Is there anything we want to address here? Great. Next is just the spec discussion. V061 is almost ready. There's a couple of PRs that I haven't had a chance to look at this morning that I'd like to get in there. It's primarily a few bug fixes and a couple of cosmetic things. There are, as we mentioned, some tests released for 0.60 on the new testing repo, and we will have those output for 0.61 as well. and we're looking about a week from now to have a more extensive set of tests for 061 to be released. So this is
061 includes the compute committee refactor, right?
Yes, yes it does. Yeah, so there's a little bit of a refactor around compute committee and Git crosslink committees, or it's actually just Git committee. Oh, actually, I can't remember what's going on. Anyway, I think it's all Git crosslink committee. That simplifies it much and makes it more general and usable in a phase 1 context that we needed. We can take a look at that PR. Cool, but just general open discussion on spec. Anybody have any questions, anything that's come up they want to chat about? Cool. Everyone's, yep.
Nope.
Yep.
Okay. Yeah, just a quick on the RPC. Like Luke opened up 2 good issues. I think he's converting them to PRs shortly for validator to beacon node communication. I think I think we also kind of missed out, but I think it'd be pretty good if we could also start defining, similar to how ETH1 kind of has the different exposure methods. So like you can expose web, admin, was it network or NAD or something like that, ETH, right? So there's like how RPC is like split up into a bunch of different subcategories. I think we should start actually defining that as well. And if we do that now, you know, we'll be better planned and we can start actually getting input from teams working on ETH1, like Ethers, Web3.js, to kind of see like where their pain points are and trying to address those early. And I've already created like a bit of a working group on that on a Discord channel, and I'm happy to share that link with everyone.
Yeah, please do.
Yeah, because I do see it kind of important if we start. I think we're at a point where it's good to start asking, you know, tooling teams, kind of, you know, pain points they've had or they have currently, and see if we can try and, you know, account for a bunch of these early on.
Yeah.
Yeah.
Agreed. As we're approaching spec freeze, I've been wanting to open up the dialogue with the Web3 people, the block explorers, the anyone that's really directly consuming these APIs. So glad to see that's getting started.
Yeah. We're going to be starting just for anybody that needs it, because Preston actually asked the other day. Our SSD.js is like ready for browser. It should be actually, but we're also going to start doing like kind of like a Web3 one. Like kind of a POC implementation of it, so that with the validator RPC, and as like kind of more RPC methods solidify, we'll keep adding to it until, you know, there's a team ready to kind of adopt it and take it on when ETH2 kind of stabilizes.
Cool. I'm personally a little bit behind on those Luke's couple of issues, but I'll be digging into that today. Any other spec stuff? Spec stuff, architecture stuff.
I mean, one thing I'm not sure we discussed before is the idea to have different slot durations for the beacon chain and for the shards. So the idea here is that maybe we can increase the slot duration for the beacon chain to something like 8 seconds or 12 seconds. And that will have several benefits. One is that it would make the beacon chain, you know, more robust, kind of as this central piece of infrastructure, and would have slightly more conservative networking properties. It would also allow us to remove the minimum attestation inclusion delay, which
essentially setting it to 1.
Mm-hmm. Right.
Right, and just quick, a common, when I bring this up to people, a common reaction is, wouldn't that increase the time to finality? And the answer is, if you kept everything else the same, yes, but you can actually, you could have if you have twice as long slots and you have twice as large blocks, as in you're including twice as many committees, you don't change the time to finality.
Right. And it also means that things like signature processing is slightly more optimal because you get in more committees per block. And I think Vitalik had a recent kind of clever trick to verify all the signatures, with just one pairing. So you amortize the number of pairings better. And then to counterbalance that, you have smaller slot durations on the shards. So it doesn't matter so much if the shards have a bit more forking. We do care about the low latency from a user experience standpoint. So we're considering bringing the slot duration for the shards down to 3 seconds, and in that way we'd be competing with the more centralized approaches like EOS.
The committee sizes on the shard, so the amount of people that have to sign and attest to each shard block is actually capped at, I think, 128 right now, rather than it just scaling indefinitely with the size of the persistent committee. And so there's a little bit of that gain in there as well for being able to have smaller slot times. Vitalik, is your proposal on the trick for calculating just requiring one pairing, is that published?
I'm actually still not sure if it's published.
Okay, I don't think any of the implementation teams have had a whack at it yet. Might be good to have somebody try it out.
I think I might have said that I would write up a doc, but then just forgot to do it. So I guess I'll just not forget to do it.
Cool. Okay, cool. Anything else regarding anything?
Yes. We're doing the workshop on the 16th, on May 16th, in Brooklyn at a place called Bushwick Generator. Come and participate. Terrence is speaking, Antoine is speaking, Johnny Ray is speaking, and it's going to be a workshop. We're going to be working specifically on interop, how we're going to get our clients to interop, and it's going to be all regarding that. Cool.
Yeah, I'll be there.
What about SSC?
I don't think that there will be specifics on SSZ at the moment. We're
gonna put anyone that wants to talk about SSZ can go stand in the hall.
Nice. Well, we're going to talk about P2P networking, and that may kind of come up like casually in P2P networking, but I think our it's mostly going to be around client interop.
I think he was messing with you.
I was joking.
Will it be remote enabled? Will people be able to dial in?
We haven't figured that out yet. Actually, a few have asked for it, and I'm gonna try to do that for sure. But I haven't figured it out yet. So I will do my best to set up a Skype session or something.
Sweet, thanks.
No problem.
Cool.
Go
on.
I dropped a link in the chat earlier. If you want to sign up, that would be nice, because then we would know how many people are going to be there.
Cool. And as you may have noticed, some of the cat herders have joined us again today. We had a good meeting, I believe it was yesterday. And I believe the intention there is they're going to start doing what they call some shadow PM. We're just going to start better compiling resources, getting information together, documenting things, with the intention of over time increasing their help with individual teams and with larger scale things like long-standing cross-client test sets and launches and things like that. So thanks, Cat Hookers. I think some of them will be able to be at that interop meeting in May. Cool. Sorry, I'm kind of losing my voice. Proto, you raised your hand again.
About documentation, is anyone working on the handbook? Somebody mentioned it's out of date. The document outlining all the different Eth2 considerations.
Yes, somebody did mention on the Gitter that it is out of date. I don't know if anyone has taken that up yet. Justin raised his hand. This hand raising.
Yeah, it's a cool feature. So some of you may have seen that the reverse time lock puzzle. Sorry for the somewhat non-phase zero related stuff. The RSA time lock puzzle has been solved, and there's going to be a ceremony at MIT on the 15th of May, and as part of that, there's going to be the unveiling of some like physical time capsule that was prepared 20 years ago by lots of interesting people, including Tim Berners-Lee and Bill Gates and Rivest and Shamir. And so if you want to join, please email me. And on the, May 17th, there's going to be a mini VDF day. So the reason these two things are kind of together is because the math behind the time lock puzzles is basically the same as the math behind VDFs. And as part of the VDF R&D, we've implemented an FPGA VDF evaluator, which we tested on the time lock puzzle. And so this time lock puzzle is a 20-year-old puzzle that was designed to take 35 years to crack, and the FPGA just takes 2 months to crack the puzzle. So there's some exciting stuff that will be kind of presented on May 15th and May 17th at MIT.
So you can make it to MIT on May 15th, make it to New York for the workshop, and make it back to MIT for the 17th.
Right.
Sam, you raised your hand?
Yeah, Jim.
Jim, I'm sorry.
So like, in terms of like SSC, like as we were going from 0.4 to 0.51, we had like so much like complexity just due to like SSC, and that like slowed us down a lot. And the reason is that like mostly like some arrays like lists are like now like tuples, and like they're all like bounded. And like I understand that like having like bounded lists like creates like efficiency, but like also for languages that like don't like normally have like type what do you call that, type invert that like for like languages that don't have like reflection without like slowing them down incredibly, that's like introducing us like a lot of complexity. I was like curious like what are like the gains from like doing that.
One of the gains was actually for compiled languages to have stronger compile time guarantees about some of these things. Another is to put bounds, known clear bounds on some of these objects, even in the context of very large things. Some of the other things might be I might be missing. Justin or anyone that worked on that?
Sorry, I was distracted. What is the specific of the question?
Apparently, putting the constant time or the constant size arrays has introduced some considerable complexity in the Java implementation for SSZ, and I am trying to remember some of the reasons that we did that. One was compile time guarantees. One was putting known bounds on object sizes and things.
Yeah, basically it was having different treatment for different types of SSZ containers. It made it rather difficult for us because it's all serialized bytes are no longer treated the same, right? For example, when you're serializing the list with the mixin goes at the front, and when you're doing the hash tree root with the list, the mixin goes at the end. And it just made it a little bit more complex to have to deal with than the previous, which is once it's serialized, it's serialized. They're all kind of the same.
Right. So I guess there's only two cases: the lists and the vectors. So I mean, I'd argue the complexity is still extremely limited. But one of the reasons to have vectors is that it means that we can have the whole spec on the SSD, including things like in phase one, having the notion of a block data as an SSD object. And one of the things that we want is to avoid, basically to have pure Merkle paths to leaves in the block data, for example. And the reason is that we're looking to do these fancy data availability proofs where the complexity of mixing in the length might make the circuits significantly slower or unworkable. So by having these fixed size things, we unlock the possibility of using, of making easier proofs for SSD objects. The other thing is that it just makes the spec cleaner throughout. So, I mean, it's a minor thing, but now when you want to initialize the beacon state or initialize any kind of object like a beacon block, you just initialize it with default values, and the type, which for vectors will basically specify the length, the number of elements, just fills everything with zeros. And it turns out that that's basically the right answer every time, pretty much. So you can initialize objects for free, which is kind of nice. And it's the same thing that Go does. So in a way, we've, I'd say SSZ typing quite closely mimics Go typing. And Go is very, very clean for that.
All right, thank you for the explanation.
Cool. Anything else before we close?
Yeah, I was gonna say that the workshop is looks like it's gonna conflict with the call in 2 weeks. So just carve out an hour, or what?
We could also just push the call another week. We've done that when we've had collisions like that. I think that's probably fine.
Yeah, and just cancel the call and like if people like possibly even try to have a live stream into that event if people wants to show up for any part.
Yeah, I think that's the way to go. Speaking of which, I have received, I think last night or the night before, I received videos from the previous session. They're like 75 gigs, so I will try to wrangle that today and get them up. Cool. Okay, anything else? Going once. Twice. Sold. Okay. Thank you, everyone. Good call. Keep in touch. I'll see a lot of y'all in New York. Talk soon, I guess.
Talk soon.
Thank you.
Thank you.
Thank you.
Thanks, guys.